VSEPR is the valence shell electron pair repulsion. The shape of the molecule is determined by repelling force of electron pairs. Electron pairs will get as far apart as possible. Electron domains of non-bonding electron pairs repel more than electron domains of bonding electron pairs. Multiple bonds repel equal to that of a single bond. Shape, name, and molecular geometry is based on the location of the atoms, not the unbonded electron pair.
Our first model is the trigonal planar, and it has 3 bonded electrons here and no unbonded. The bond angles are 120 degrees, and it is called a trigonal planar because it creates this triangle and it's all on the same plane. This molecule is nonpolar because the negative charges here are all centered in the middle with the positive charge. It is on the sp2 orbital because it has 3 electron orbital domains, and sp2 contains 3 electron orbital domains. Our second molecular model is the trigonal planar bent. It has 2 bonded molecules here and 1 unbonded here. It is called bent because the non-bonded electrons here has a stronger repulsion and pulls these 2 electrons closer together. So this bond angle here is going to be less than 120 degrees, and this bond angle here is going to be more than 120 degrees. This molecule is polar since the center of the 2 negative charges will be here and the center of the positive charge will be in the middle. It is part of the sp2 orbital domain because it has 3 electron domains. Our third molecular model is the tetrahedral. It has 4 bonded electrons and 0 unbonded. The bond angles between each electron is 109.5 degrees. It is called a tetrahedral since there are 4 equally bonds around the molecule. This molecule is nonpolar since the negative charges on the electrons are all centered into the middle with the positive charge. And this is part of the sp3 orbital domain since there are 4 electron domains and the sp3 contains 4 electron domains. Our fourth molecular model is the tetrahedral pyramidal. It has 3 bonded electrons here and 1 unbonded here. It is the pyramidal since the bottom 3 electrons form a pyramid shape, and this molecule is polar since the 3 negative charge electrons will center here and the positive charge will center here. It is part of the sp3 orbital domain since it has 4 orbital domains, and the sp3 also contains 4 orbital domains. Then the angles between the electrons is less than 109.5.
Okay, our fifth shape is the tetrahedral bent. The tetrahedral bent has 2 bonded electrons and 2 non-bonded electrons. The bent shape here is because the 2 non-bonded electrons have stronger repulsion and push the non-bonded electrons closer together, which results in an angle less than 109.5 degrees. This is nonpolar because the center of the negative charges is here and then the positive charge is here, and it is part of the sp3 orbital hybrid orbital because it has 4 orbital domains. Our next molecular shape is a trigonal bipyramidal. This shape has 5 bonded pairs and none non-bonded. The angles are 120 here and then 90 between these. And then it is called trigonal bipyramidal because of the triangle that is formed here and then the 2 pyramids that are formed here and here. And then this is a nonpolar because it has the negative charges center here along with the positive charges center, and the hybridization is dsp3 because the 5 electron domains, there are 5 electron domains around the central atom. Our next molecular shape is the trigonal bipyramidal seesaw. This shape has 4 bonded pairs and 1 non-bonded pair. The angle measurements are undetermined, so we don't know what they are. And the shape name comes from the seesaw look of the molecule and how it moves once you form it. And this happens because of the repulsion from the non-bonded pair at the top. And this is polar because the center of the negative charges are just below the center of the positive charge. And it is part of the dsp3 hybrid orbital because it has 5 electron domains around the center atom. Our next molecular shape is the trigonal bipyramidal T-shape. This shape has 3 bonded pairs and 2 non-bonded pairs. The angles here are 90, 90, and then 180. And then after repulsion from the non-bonded, when these two lose electrons, there's repulsion and pushes these down and creates the T shape. And this is a polar shape because the negative charge is slightly underneath the center of the positive charge. And this shape is in the dsp3 hybridization because of the 5 electron domains around the center.
Our next molecular shape is the trigonal bipyramidal linear. This has 2 bonded and 3 non-bonded, and the angle between the bonded is 180 degrees. And this molecule is called linear because the bonded molecules are in a line, and it's non-polar because the charges of this one is in the center along with the positive charge of the center, and is in the dsp3 hybrid orbital because of the 5 electron domains around the center. Our next molecular shape is the octahedral. It has 6 bonded and 0 non-bonded. Each angle is 90 degrees, and it gets its name because there are 8 connected triangles with all of the atoms. This molecule is non-polar because the negative electrons in the center is in the same place as the positive in the center. And then it is in the D2sp3 hybrid orbital because there are 6 electron domains around the center atom. Our next shape is the octahedral square pyramidal. It has 5 bonded and 1 non-bonded. All the angles are less than 90 here, and then more than 90 here because of the repulsion of this unbonded electron. This gets its name because there is a square formed between these 4 and a pyramid using this one as the top going down. This molecule is polar because of the repulsion. The negative charge will be down below the center and the positive charge will be in the center. This is also in the D2sp3 hybridal orbital because of the 6 electron domains. Our final molecular shape is the octahedral square planar. There is 4 bonded and 2 non-bonded. All of these angles are 90 degrees because of the equal repulsion from each unbonded pair. This is called a square planar because a square is formed and they're all on one plane. It's also non-polar because the charges are in the same place as the positive charge in the center of the molecule. And it is in the D2sp3 hybrid orbital because of these 6 electron domains.